See, in entire generative AI, you just have to learn these 4 things. If you learn these 4 things, you will be in good position than at least 90% of the people who know the AI. First is LLM. Second is I am writing LLM and prompts here. AI tools, RAG, AI agents. If you learn these topics, you are already far ahead than other people. There is no one way of learning these things. These are all interconnected. These are all interconnected. Meaning of like prompts are also for LLMs. They are also for AI tools. They are also for RAG. They are also for agents. Prompts is what? You put some instructions or you give some instructions to the tools, models, systems, whatever. Correct? What I am saying is making sense? Agents. What are the 3 things required for agents?
LLMs, tools, memory.
So interconnected with? Of course, here what we have. So when you learn, you will find out what?
Memory.
And other lot of tools. LLMs are already here, so I just connected it. So what I'm trying to tell you is, to Gen AI, these are the 4 things. You go anywhere. Conference, events, interviews, job place, startups. It's all surrounded by these. You guys have got fair bit of idea of these things for now. What is that? Little bit of this, but you got no idea of these 2 for now. Like agents little bit, but no. Correct? So the day we'll complete all these 4, will be in good. A couple of more things like MCP that we have to learn, but that comes under agent only. Okay, we learn MCP, model context protocol, but that will come. Why I am showing you this? Because we are moving towards RAG, retrieval augmented generation. So we'll write that. Okay, retrieval. Spelling, what is retrieval spelling? I hope this is right. I don't know. Augmented and generation. Retrieval augmented, I think this side will be better. Retrieval augmented generation. See, let's say I have this documents. Okay, same soft copy. Visualize this as soft copy. PDFs that you have in your machine or your machine. The thing is, we have understood about this word context. Context window, remember?
Sir.
Who will tell me? Context window.
Number of token limit.
Very nice. To learn whatever you are learning, before you should ask this question. First tell me why the hell are we learning that? Let's say this is an LLM, GPT-5. GPT-5 is an LLM. Which company? Okay. Let's say I also writing the new guy on the blog, Gemini 3. By whom? Very nice guy. See, we have to understand LLM is static. Agree or not? Knowledge cutoff has been trained till certain date. But okay, now I have this 100 of PDFs in my laptop. So there are 2 ways. Like let's say all these are what? PDFs. What are these? PDFs. I am writing these as data. Now there are 2 ways we can use this data. LLM can use this data in 2 ways. So first of all, think this like as an AI system. What is this?
AI system.
AI system. 2 ways this AI system can use this data. What is 2 ways? So see, first of all, we have to read this programmatically. So the PDF are there. How would you read this file? So first of all, what language we are using for all this?
Python.
What language are you using? Python. So we know that we are writing code in Python. So if we give this PDF file, we have to read that using Python language. After reading, it will what? Extract. What it will do? Extract. Extraction means what? Extracting all the data which is there. Text data hoga na? Documents are image, text, whatever tables, whatever are there. And once it pulls the information, it can give it to what? Prompt me. Can give it to prompt and give it to this AI system. What it will do? Output. This is one way, getting clear. So let's say the task here is summarization, summary. I will give all this research paper and I will say create a system that will summarize this. All these 3 papers should be in one paragraph. Prompt I am writing, simple prompt. Read all the text below and summarize it. I am not doing any system prompt, I am not doing any role pattern format. Just the one line I am writing just to explain you guys. Read all, this is all. Read all the text below and summarize it. What I am doing? Summarize it. And here I will write all the text. What are these text? This text, whatever it is going to extract. These are all 3 research papers. But let's say these have 1 million context, 1 million word in these 4 files. If there are 1 million words, what will happen? We had what? 1 million words. We have fit to prompt, and this prompt goes where? Used by any LLM. That can be Gemini 3 or GPT-5, any model like let's say. What is the first problem here? So lost in middle is the first thing. So hallucination? Very nice guys. Hallucination. Speed क्या होगा?
Latency.
Because nowadays model have so big of context, you can feed 10 million word also. Means you can feed your entire data into one prompt. But then if you feed, you will find out all these problems. So see, when we do RAG, so how will this work? This is my what? PDF?
Yes.
What we'll do first? Read.
Extract.
And then what is the next step? So extract will give you what? Raw text, right?
Yes.
The way text is there, it will give me that. I am not doing any processing on it. Processing, you guys know, cleaning, wrangling. It's called pre-processing in machine learning. So far we have not talked about it, right? So when you extract the data, what do we do after it? We extract text when we go into a part called chunking. Why? Because this is a bigger, like let's say 1 million head. This is 1 million tokens I am writing, okay? Chunking is the most important part of building a better chatbot. Chunking strategies. There are different ways we can do chunking. One shoe does not fit all. See, chunking strategies. What is chunking? Method to split text. Simple definition. Method to split text into manageable pieces or small units. So chunking strategies are of different types. So this 1 million that word we have, 1 million, these are what? Raw text, whatever we have, we need to chunk them. Why do we chunk them? We chunk them so we can create a vectors. And then what we get? Vector. After vector, what do we do? So I am writing vector DB. And what do we do? Last chatbot. Augmentation part. Okay. So this is the entire process of RAG, by the way. We start with chunk. Then we go into vector. It's called vectorization. Or it's called vectorization. In that what we do? Take the chunk and convert that into very nice. We are giving some IDs to each word. Then we'll find out similar words. But finding out distances between words. So, why is chunking important? First of all, working with large documents. When I said, when is chunking required?
Large document.
Read it. Breaking into smaller pieces so we can create vectors. We can store those vectors to vector database. We can use that vector database in our chatbot to retrieve information.
Yes.
Correct?
Yes.
Where do we use chunking?
Racks.
If anybody asks you what is the first part of building a rack, what will you say?
Chunking.
What is this?
Context limit.
We just discussed about context limit.
Yes.
So not all models have what? Bigger context limit. There are models which have smaller context limit. So if that is, let's say my total word is 1 million token, and there are model I have chosen which only has 128k 8k as window limit. So I can't use that. So what I have to do? RAG. What is last one?
Document analysis.
You can also write that in your use case. Question answer, summarization, chatbot. You can also write document analysis. Why is chunking important? So you have to say all these. What is chunking? Define like this. When to use and all is there. I love banana. I am writing three words. Tell me which words are similar. First and
Second.
why are you saying it?
Sir, because I love like mango and banana both are fruits.
Like it is describing what a
You can
person likes.
distinguish.
Both have similarities.
Very nice. The word you said, focus on the word similarity.
Yes, sir.
You see I. So there are two ways to say it. One is keyword based, the other is semantic based. We'll discuss both. Semantic. Remember the word I told you to keep in mind, semantic. First is, look at the similar words. Direct similarity. First is what? Direct similarity. What are direct similarities?
I love
I love.
Boom.
mango, banana.
Correct? These are called
Direct.
keyword matching.
Similarities.
How can we find similarities? Two ways on very high level. One is keyword, another is
Yeah.
semantic. See, this word banana and mango, how do we find out these two sentences are similar? They're based on, so these will be all be converting into what? Numbers first.
Yes, sir.
This will be converting into vectors, numbers, whatever, and will be saved where?
Vector data.
Vector database. Vector database will also be two types. Open source and closed source.
Yes, sir.
We are open source lovers. I like open source.
Yes, sir.
Without open source, we will die. In technology, we will die. In life, we will not die. Okay, so open source. It's called Qdrant. Or open source. Qdrant, Weaviate, Milvus, ChromaDB, and FAS. These are open source vector database or vector store. I will tell the difference between database and store also. There are more, there are thousands of others. In closed source, Pinecone is the leading vector database. Pinecone. Okay. My favorite is Qdrant. Also, FAS is by Facebook AI Search System. The full form of FAS is Facebook AI Search System. Facebook
Yes.
AI Search System. It's created by Meta. It's created by Fair Lab at Meta.
It's
Facebook
his,
AI Research Lab. So FAS is good for what? Like let's say 50 documents. So there's a difference between store and database. Like let's say you have a Kirana store and you go to
Mall and Kirana store.
Kirana store versus mall. Similar funda. So people use ChromaDB and FAS for what? For as a vector store because they are small for few data. But always remember, FAS is written in C++, extremely fast.
C++.
And Qdrant is written in Rust. It's also available on GPU and CPU, by the way. So if you are using a CPU machine, you have to use fast CPU. Okay. So two best vector stores are FAS and see if you look at here, Chroma is there. I said Chroma. All these are here, right? Pinecone, Qdrant, Milvus, Weaviate, FAS. This is my sample text. What is this?
Sample list.
Sample
Not
list.
text.
Something that will come from the file also. So look at this sample text. So what we are writing here? We have created a sample text. Total character how much? Total word how much? Okay. And this is our sample text. 500 means we are only looking at the first 500. Okay. This is getting clear. This is something that we created. What is this? This is dummy data. What is this?
Dummy data. Synthetic data.
Synthetic data. This will come from your PDF file. You will do f.read. Correct? So just do f.read and then you print f. or whatever.
Okay.
Whatever it is. Okay. So, see, chunking strategy. We'll wrap it up here. I just want to explain this. What is the first one?
Character level.
Character level. Second one?
Word level.
Third one? Sentence. Paragraph. Page level. Pretty easy to understand. Where is the research paper? Give me. Give me one paper. Like, one paper. See, this heavy paper, man. Put multiple papers in it. Say this is one paper. There are multiple files. I say, okay, I want to chunk it now. So if I want to chunk it, and if I do page level chunking, so what I will do? This becomes one chunk.
For every page.
This becomes one chunk. This becomes the other two chunks. This is called
Chunking.
cycles. Look at here. This is what?
Page level.
Page level chunking. Now tell me what is what level?
For every word.
Every word. The most difficult one here is
Semantics.
semantic. What is semantic chunking? In semantic, we'll find out what? Intent and entities. That is difficult. That's why it's in last.
Yes.
These are easier to chunk. So we'll see it. Because easier to what? Just set your rules. You know what is the meaning of setting rules?
Yes.
I will just create the rules. I know what the meaning of a word. Acha, tell me, how will you count word also? Nobody will tell. How will you count word?
Space.
Very nice. That's a very good idea.
So which one is better according to you?
What is
Like
it?
character level or like
No. It's not about better. It all depends on use case. It depends on documents that you have. We'll see that.
Then if you use the character level, it will be fine. Or it will not.
For all use cases? No.
See?
No. What I'm saying you, I'll come to that. You get confused. See, there is nothing best, nothing wrong, nothing right. It all depends on use case. Use case.
To avoid this problem, we can use.
These problem, character level. If you have these kind of thing, you do character level chunking. We will see. I mean, chunking, why I'm saying you, chunking is very critical. If you get the chunking right, then all you will be chatbot will be good. Always remember, there is no one best chunking strategies. If I show you best chunking techniques for complex video, if you read these threads, they will tell you it's not about, see, we have semantic chunking also. Right? There are discussions happening. From this you can find out what kind of chunking people are using for what kind of document. So you can learn from other people. It's easier to learn from other people rather than you doing and trying yourself, because you can just find out their results and you start from there. Chunk by title. Chunk by title is what? Let's say you have this paper. This is what your title. So every research paper, it will chunk by title. So it all depends on what you are solving. Okay, I'll tell you. Let's say I have thousands research papers, 10,000 research papers, and I tell you every paper I need a summary. What chunking is it? Titles. The way is, go on my YouTube channel. Okay, there is a very good video. I'll show you.